All right, we're going to be covering 3.2, the quadratic functions. This is part 1. All right, the standard form for quadratics, and I want to mention here that I'm using capital letters, but in this case, in this particular setting, for me, this time I am using both capital and lowercase letters, and they are the same. So if it's a capital A or a lowercase a, those are going to be the same for this lesson. All right. So the standard form of quadratics, we have ax squared plus bx plus c. Now a, b, and c are all going to be a constant number. They're not going to change. The other piece of information that you have to have is that a cannot be 0. Because if you have a is 0, all that's left is bx plus c. Well, bx plus c is the same as mx plus b, right? That's just going to give you a line. So you have to have that squared in there for this to be a quadratic. The shape of the graph for a parabola is always going to be like a curve. I joke about the fact that if it's positive, it smiles. If it's negative, it frowns. But it's going to be a curve. It comes down, hits a maximum or a minimum, and then it curves back to towards its origin. So it comes down and finds a min, and then goes back up, or it comes up and finds the max, and then it goes back down. So a couple things you should know. When we talk about a is greater than 0, the parabola does open up, and I call it smiles. And then a less than 0, the parabola opens down, or it frowns. The c is always the y-intercept. Parabolas are symmetrical. Because they're symmetrical, there's an axis of symmetry through the vertex. All right, and in this case, I'm going to show our axis of symmetry. Right here is our axis of symmetry, and I'm going to show where it crosses our x-axis. Here is our axis of symmetry. It's as a result of, there's our vertex, right? That's our vertex right there. Here is also our vertex, an axis of symmetry. And then it's possible to have one that's not either touching or crossing the x-axis. And we'll talk about that in just one second. The axis of symmetry is going to become really important here in just a moment. And we'll talk about why that is. I want to make sure that folks can see that there's a couple options when you're talking about a parabola. The number of solutions you can have varies. So you could have, let me use red actually, so it's nice and visible. You can have 2 solutions. You can have 1 solution, or you could have no solutions. And when I say no solutions, I mean no real solutions. That does not preclude the fact that there is a complex number that can be a solution. All right. In each of these cases, though, I'm talking about real numbers because they cross the x-axis, or we touch the x-axis. All right. So a little bit to keep in mind, we already know how to find the x value of the vertex, right? That x value of the vertex is minus b over 2a. We've talked about that previously. It is not a big deal, that minus b over 2a. And it's very easy for us to just kind of get into the groove that that's our vertex, but it also gives us our axis of symmetry if you stop and think about it, because that line goes through our vertex. So anytime you need to find the axis of symmetry, you can use the minus b over 2a. When we calculate, and then we can calculate whatever the f of x value is to find out the point of the vertex if we need to. I want to point out a couple of things. First of all, just because something is written, I could have this written as 1 plus 4x squared plus 4x. And if I have it written like that, this does not become a. A is always paired up with my x squared. My b is always going to be paired up with just plain x, and c is always going to be the one that stands alone. Okay. So when we talk about real solutions, I talk about them as solutions, but other people may call them roots. Okay, so a root is where a function of any sort crosses the x-axis. So we can see from these parabolas, we have the possibility of 2, we have a possibility of 1, we have a possibility of none. All right, so just going to quick go and show you where, using this, we're going to go ahead and find our axis of symmetry. So my negative b, which is a 4, divided by 2 times 4. And now I can cancel my 4's out, and I'm going to get a negative 1/2. So the x value for my axis of symmetry is negative 1/2. Now the next part, we want to define the actual vertex, right? That ignores, it stops being about the line of symmetry and starts being about the specific point, whether it's the minimum or the maximum. What you would do is you would take this negative 1/2 and plug it in everywhere. All right, so to do that, let me go ahead and change the color so we understand that there's something new going on. All right, so there's a 4, and then I have x squared with a negative 1/2, and that's squared, plus 4 times negative 1/2 plus 1. All right, so if you stop and think about it, this becomes 4 times 1/4, right? Because negative half and negative half multiplied together gives you a 1/4. 4 times 1/2 is going to, or negative 1/2 is going to give you a negative 2 and plus 1. All right, this becomes a 1, right? So I have a 1 minus 2 plus 1, which is going to equal 0. So my ordered pair here is going to be negative 1/2, 0. That is the point of the vertex. All right? And when that happens, when we have exactly the vertex, right? When we have exactly the vertex, just touching, it's just touching the x-axis. It can be anywhere along here. You're going to have one solution. Okay, you're going to have one real. Here, of course, you have 2 real, and here you have no real solutions. All right. I'm going to talk very briefly about degree, and then we'll see about stopping our video and restarting a new one. All right, so a bit about degrees. The degree of an expression is the highest exponent on the variable. In the case of quadratics, the degree is 2. If you have a cubic, the degree is 3. If you have a quartic, it's 4, and so on. Okay? So the degree indicates the maximum number of solutions that are possible. It does not mean that they have to have that many. It means that that's the most it can have. Okay? So if you were to do a problem and you use, you're using a line, your degree is 1. So if you found two answers, something's wrong with that picture, right? If I'm going along, I'm doing my quadratic, and I come up with 3 or 4 solutions, I know that something's wrong. I've made a mistake somewhere because it doesn't work that way. We have the degree, and that lets you know the maximum that you can have. All right.